Hi guys and girls on YouTube, and welcome to my channel. In this video this week we're going to be looking at this 14-inch Sony TV. Now this actually belongs to a friend of mine, but originally it was my TV. I had back in the year 2000s, when I was doing lots and lots of Skybox, I had 4 of these TVs running, and that's why it's labelled up monitor number 2. But when I actually towards about, I don't know, 2010, the demand for Skyboxes have actually dwindled because Sky are giving them away for virtually nothing. And in 2013 I actually decided to close my high street shop and I moved to this industrial estate. So the friend that this telly belongs to, I actually gave it to him in about 2013. Now if we look on the back, let's get the back. So it probably dates from about the 1990s. So I put the date on 7/6/2003. So 2003 to 2013, that's 10 years I used it. And it was probably quite a few years before it was actually bought brand new. It's a KV-M1421U. Now the most common fault on these, they used to go dead, and it was a really simple, easy money maker. It was just caused by a circuit protector. Let's have a look down there, and yeah, just there, I think it's an ICP. Is it ICP? I don't know. I'll have to look at the service manual. Yeah, it's an N15. So the 15, you times that by 40 and that gives you current rating. Now they used to just blow for no apparent reason, and you'd have a dead set. And you can see how efficiently these sets run. The line output transistor there doesn't even have a heatsink on. That's how efficient these were. But I mean, this is a really old TV now. Now my friend says it's completely dead, but unfortunately it's not the circuit protector. That's okay. So what I thought we'd do, I'll get the manual out, we'll take a really quick look at the diagram, and I'll just explain a bit of the circuitry because it's a bit unusual. Some of the circuitry used in this, this is probably a 90s TV, it was actually used in the 70s, so the actual circuitry a bit of this uses is well out of date. So let's just take a look at the manual first. Right, well that's the service manual for it. It's a BE2A chassis. Actually took me quite a long time to find this actually because I've got that many manuals. Right, so that's actually the circuit protector there, and all it does is it feeds the HT rail to the line driver transformer, and also to the primary winding there, the line output transformer. But unfortunately there's no easy ride with this because that is okay. So what's so peculiar about this circuit and the startup of it? Well, if we look at that there, that's the jungle IC, which contains the line oscillator IC. And if we look at pin 8, you need a supply on pin 8 to start the line oscillator. So if we move that there, VCC, back to where it comes from, you'll actually see it comes from a 3-terminal regulator, 16 volt in, 12 volt out. But the input from this doesn't come from the chopper power supply, it's actually line derived. It comes from the flyback transformer. So how on earth can this set start up without the line output stage running first? Because the line output stage, when that comes into operation, that actually powers the line oscillator. And the key is, this is what you call a kickstart circuitry, and it's a very similar principle that you used in some very early Taches in the 70s, and also in the Bush, is it Z718, 719, where a capacitor is charged up from a voltage, and that just kicks the line off. That just kicks the line output stage into operation. One single pulse, and then when the line output stage comes in, that powers the oscillator. So if we move back down here, and where is it there, the 20 volt rail, that's the chopper transformer there, that's the power supply. So this 21 volt rail, it actually just kicks that capacitor. It supplies a kick voltage to that capacitor, which is the base of the line driver transistor. So the idea is a quick pulse there will fire up this transformer, which will in turn bring the line output stage into operation, and then once the line output stage comes into operation, the line oscillator is fed from this auxiliary winding. Now, bearing in mind the set's completely dead, the first thing we need to change then is that kickstart capacitor there. But unfortunately, I've already changed that and it still doesn't work. So let's have a quick look when we switch this set on what happens. So turn it on there, press the button, you hear it dig out, there's a single flash there, or was it 2 flashes? But now the set's completely dead. It's not actually come on, all it's done is dig out and that's it. So with a kickstart capacitor of only 0.47 microfarad, which also couples the line oscillator, it serves 2 purposes. It couples the line oscillator drive as well to the base of the line driver transistor. With a value that low, we've only got a split second, and if the line output stage doesn't come into operation, the set stays dead. Now, if you remember in the Bush 718, 719s, I think the value of the kickstart capacitor was about 10 microfarad. So what we need to do, so we can actually make more checks on this, because we can't find any fault in a split second, we need to get, where are we going here? We need to get a 12 volt bench power supply onto pin 8 of the line oscillator IC, and then at least we can see if there's any line drive coming out of it. So the first thing we need to do is just confirm we've got the 120 volt HT rail and that the power supply is running correctly. So the easiest way to do that is to measure at the collector of the line output transformer, because that 120 volt will go straight there through the primary winding of the transformer, yeah, there, and through that circuit protector. So if we've got 120 volts at the collector of the line output transistor when the set's not running, we know the power supply is working. Right, so here we go. That's the collector there. Yeah, and we've got 126.0, so the power supply is running. It is of course unloaded. So what we've got to do now is get that line oscillator running with an external bench power supply. So the easiest place to connect a 12 volt supply is straight to this regulator, pin 2 earth and pin 3. We're going to connect that to a 12 volt source. So that's the wires connected to the regulator. Now the reason I say that's the best place to connect it is because the chassis is only half out, and the line oscillator IC is right down at that bottom corner down here, so we'd have to pull the chassis out more. So that's the most convenient place. I've connected to a bench power supply, 12 volt. I've set it to 1 amp. Let's turn it on. So we're drawing 443 milliamps. There's a green light on front of the telly. Now at this point we've not got mains power to it. We're just running straight from that bench power supply. So I've got the oscilloscope running. What we need to do now is check the base of Q801, the line driver transistor. Now we can only check the base at the moment because we haven't got the set powered up and the collector goes through the transformer to the main HT rail, but that'll tell us that base there if the line oscillator's running. Right, so here we go, scope's running. Whereabouts is it? It's that one, that N1 just there. That's it. And as you can see, we've got line drive, and that is actually coming from the jungle IC. So we know the problem is not with a jungle IC. The problem is further in the line output stage. Right, now I've checked the line output transistor, that's okay. And there's quite a few different rails actually coming off the transformer. That's the video output rail, the G2 rectifier. But I would imagine if one of these was faulty, we'd have seen some more life in this set, and it throws suspicion on the line output transformer itself. So what I'm going to do now is, with a line drive running all the time, and the TV is connected to an isolated bench power supply, I'm going to plug the telly into the mains, which will then give us the 120 volts at the line drive transformer. So that will effectively drive that transistor. Then we should see some activity here in the line stage. Or if the transformer's faulty, we might not see any activity. But if that's faulty, I would expect that transistor to start warming up pretty quick. So let's do that next. Right, so here we go on the mains. I'll switch it on there. And nothing at all has happened. So we need to get back to the scope now. Turn it off, and we need to scope up to the line output transistor and make sure there's drive at the base. Right, this is interesting, and I'm jumping the gun here. I can see the mistake I've made. So we've got base drive, we've got the line drive there at the base of the transistor, but when I turn on the main, so it gives the 120 volt HT rail here, we don't have any drive at the collector. In fact, when you turn it on, it kills the drive at the base. I'll just show you that. So there's the line oscillator running, but when I turn the set on here, to power up the HT rail, the base drive disappears, and then I turn the telly off, and you'll see it recover in a minute. That's it, the drive's come back. But look at this, I've jumped the gun. What I haven't noticed is look at the amplitude of the drive. 480 millivolts. Well, it's peaking on about 500 millivolts. We need 0.6 of a volt to actually turn the transistor on. So although we've got the correct drive, we haven't got enough amplitude. So I'm wondering now if it is this chip that's faulty. And if we look at the waveform, just to confirm it there, the waveform at pin 16 over here, we should have an amplitude of 650 millivolts peak to peak. I think now the sensible thing to do would be to change that chip, TDA4504B. So let's have a look in the stores. Well, would you believe it, I haven't got one. I've got 4500, 4502, 4503. We need a 4504, and the next one up is a 4505. So I've got all these parts and don't have the right chip. So I think it's the chip. I might be wrong. The problem is my friend doesn't like spending money. He doesn't want me to order a chip just in case that's not the problem. So he's come up with this. He's got another telly exactly the same, and what I can do is I can take the chip out of that and I can make sure it is that, rather than just ordering another one. And again, this is another one of the tellies I've given to him. What's that? 23rd of the 12th, 2010. Right, so I've actually got the back of it. It is a very slightly different model. It's the same basic chassis. But you can see here this doesn't have the Teletext module fitted, but the rest of the chassis is the same. So what I might do first, I might just make the same test on this one before we swap the chip over. Now, as this set works, I've just desoldered the secondary pins of the line driver transformer that goes to the base of the output transistor, because we don't want this set coming on, because we know this is definitely working. So I've done the same test. I've got the low voltage connector there, 12 volt. I'm scoping the base, and interestingly enough, we still have a very low base drive. But watch what happens when I turn on the power here. Straight away the base drive goes up. And then you'll see it fall again. So that's strange. It still could have something to do with that chip. Certainly this behaves a lot differently when you turn it on. We get enough drive to drive the transistor. So I'm going to stop the camera a minute while I just think about this. Right, so I've done the same test on this now. I've swapped the tellies over. I've disconnected the secondary, the line driver transformer. That's how it was before. I turn it on at the mains here, and it straight away it just kills the drive. So we can now eliminate the line output transformer. There's a possibility it's a line driver transistor, or it could be the IC. So I'll just check the transistor. If that's okay, I'll swap that IC over. It's only a second's job. There's only 28 pins. Right, so it's not the line drive transistor. Let's just swap that IC now. Right, so I'm getting deeper and deeper in this set now. I've not changed that IC yet because I've just had another look at this diagram and I can see what the problem is. I wonder whether there's nothing wrong with this set. It's probably just in standby. So if we have a look here, the horizontal output, that's your line drive output, and that's when you turn the set on, that's what kills, well, that's what dies off. So we trace that back. The line drive output goes through a resistor. If it goes down here to the base of the line driver transistor, but if you follow that line up here, it goes to a transistor called the standby transistor. Now what that transistor does, when that's turned on, it just shorts that collector straight to ground, which kills the line drive. So that is why when you turn it on, it's killing the line drive. I think there might be nothing wrong with this set all along. It might be just in standby, and what this will do through the microcontroller up there, it'll remember the last state, so when you turn the set on, it comes on in standby. So what I need to do now to make any more checks is I need to disconnect the collector of Q007, because it could be his remote control's faulty. It might be nothing at all wrong with this set. So let's just disconnect that collector Q, is it Q007? There. And you can see it goes there, look. Just shorts the line drive straight to ground. Right, so I think that there is Q007 surface mount. It's not going to be easy to disconnect the collector. I think I might just short the base to emitter to turn it off. Right, so rather than try and disconnect the collector of that surface mounted transistor, I've just shorted the base to emitter with a piece of wire to keep that transistor turned off. Let's have a look if you can see it here. Yeah, just a little bit of wire there. So I've got the same test as before. We've got that the line driver's disconnected. I'm get ready to turn the power on. So that's the drive. Last time we turned the power on, it killed the drive. Let's see what happens now. There we go, we've got full drive. So I wonder if there's nothing at all wrong with this set apart from it was in standby because his remote control's not working. I think the thing to do now is disconnect the external power supply. We'll just leave the short on the transistor, and we'll reconnect the line drive transformer. So let's just turn that off. Right, so let's see what happens now when we turn it on. Well, I heard EHT come up. Yeah, got channel number on the screen. So all that time spent, there was nothing actually wrong with this in the first place. It's just in standby. Right, well, we're not out of the woods yet. We know it comes on when we disable the standby transistor. So I've got a remote for it now. Both these sets are sitting in standby. They've both got a red light. Interestingly enough, the faulty one, the light isn't as bright as it is on the other, but that could just be because this is dirt. It might not indicate a fault. But look what happens when I turn the set on, or turn them both on. So if you look at that one, we've now got a green light and the set's come on. I've just heard the EHT, but this one we don't have any light lit at all. And then if I put them back in standby again, they've both got a red light lit. So I wonder if maybe it's just the standby transformer, but I'm going to have to take the voltage reading and compare the base with the other when it's switched, and it could be that faulty, or it could be a microcontroller problem. But at least now we know it's not the line output transformer. In fact, we know it's not the line output stage either. Right, so in the set that won't come on, we've still got 0.7 volt on the base, when the set should be on. There should be 0 on the base when it's on. So we're looking at wherever that goes to, which will no doubt be a microcontroller fault, but I'm going to have a look because it seems to go to different places. Right, that's straightforward enough. There's only 2 places that base goes to. When you trace it, it goes right round there, and it goes to another transistor there called the standby amplifier. Now that takes its base command from the microcontroller, so that should go high and low and turn that on and off. So there's a possibility that's leaky, or it's shorted out, or the microcontroller is stuck high on pin 41. But the other place it goes to is right over here. It goes to these 2 connectors in. It's a standby. Now I presume that is the Teletext board, so we could just, for a quick test, we could just unplug the Teletext board and see what happens. Right, so that's the Teletext board. I've already unclipped it. We'll just lift that out. Let's have a look now. The set's on. We've got a standby light. Let's just press a button on the remote control, and that's your answer to that. It now comes on with a Teletext board disconnected. So there's a problem on the Teletext board. Just turn it around. Yeah, it's off. That's off. Press it on again. That's back on. So the fault's on here. So we don't have Teletext service anyway. So you could just leave that unplugged, but curiosity's got the better of me. I'm going to have a look on the manual what that standby pin goes to on the Teletext board. So I'll come back in a minute. Right, so the Teletext diagram's on the other side of this, and the interesting thing is the pin label standby, if you follow it round there, is actually an input to the base of a transistor. It's not an output. So I wonder what could be wrong, but I'll tell you what I'm noticing. There's 2 circuit protectors inside there. Let's just whip the can off and have a look. Right, if you have a look, something's got very hot there. But when I turn it over, it's 2 resistors and a transistor, which I've probably done many moons ago, and that chip looks like it might have been resoldered. So the two circuit protectors, I've checked them, they're alright. What do? Do I just leave this out and send it back? Or do I have another? There's a two circuit protector. Or do I look a bit further? I'm going to look a bit further, I think. Right, so given the fact that that there is an input to the base, not an output, the only thing that can make that stick high level is if we've got a leak between base and collector on that transistor. So what I'm going to do is just take that out and then plug the Teletext board back in and see what happens. And the answer is, yeah, the set works absolutely fine with that little surface mount removed. And yes, it does indeed have a base to collector leakage, which is what's holding the base high. So I've come this far, I might as well just put a new one in now. It's a what we used to call a digital transistor. It's pre-biased with resistors, so it can be just turned off on and off for a logic level. So it's a DTC114EK. Right, so let's have a look here. We're in a different room now. I've got these drawers in both rooms. Climb up here. DTC 114, that's the one. Right, the only slight problem is the 114EK is surface mounted, and the one I've got, the 114F, is not surface mounted. But can we surface mount that? I don't see why not. Right, well that's the non-surface mounted one. MPN digital transistor correctly identified. Right, there you go, look at that. That is how you surface mount an ordinary transistor. So we've gone from that to that. Let's see if it works. So yeah, I've just soldered 3 wires to that little surface mount so we can test it. Yeah, short circuit between red and blue, which will be collector and base. And here's the tellies, they're both connected up. I haven't got a SCART splitter, so one's on RF and one's on SCART. This was the one that didn't work. They're both sitting in standby. We need that one off external input. I think I tuned it about channel 26. Oh no, 55. Right, let's put the skybox off colour bars.
I'll be back. Open Spotify.
Next up in our ones to watch,
Stand by.
Spain's youngest ever goal scorer.
Yeah, one light's a little bit dimmer than the other. I think it's just dirty. But anyway, let's put them in standby. And there you go, they're both in standby. So there we go, guys and girls, a good result in the end. I know I've made mistakes in the diagnosis along the way. But you know, a long time has passed since I repaired CRT stuff. And a lot of the things I used to know I'm beginning to forget. But anyway, there we go, a good result. We got there in the end. Many thanks for watching. and I'll catch you in the next video. Goodbye.